Okay, my secondary math 2 class, we are reviewing today this last unit, which we learned graphing inequalities and equations, okay? So just so you know, since today, Monday, is a review day, Monday, November 2nd, should be the day that you are completing these notes and doing your assignment. That means next time, November 4th, Wednesday, is going to be your test. So just like every other test, the review assignment that you'll do today will be the exact same format, exact same types of questions. The only things that will be different will be the numbers on those questions, okay? So let's get right into it. Okay, so let's look at number 1. So our instructions, our directions for number 1, it says to draw a graph for each inequality. So we can see that our variable is already by itself, so we can go ahead and just graph it. Okay, so what number on my number line am I going to place my point? At positive 4, right? Is this going to be an open or a closed point based on my sign? It's going to be a closed or filled in point. Okay, so closed point at positive 4. And now we need to know how to shade it. Which way are we going to shade it? If this is saying x is less than or equal to 4, where are my numbers getting less than? Less than 4. To the right or to the left? To the left. Okay, they are getting less than or smaller as you go into the negatives, right? So you're going to shade to the left. You could also say that since my variable came first, my sign is pointing to the left, I can shade to the left. Okay, let's look at number 2. So again, our variable is all by itself, so we can just go ahead and graph it. So on what number on my number line am I going to put my point? I'm going to put my point at positive 3. Is it going to be an open or a closed point? Ew, that's an ugly arrow. An open or a closed point? This one's also going to be a closed point because of the or equal to. Okay, so another closed point at positive 3. So now, which way are we going to shade this one? If n is greater than 3, which way are we shading? Where are my numbers on my number line getting bigger? To the left or to the right? To the right. Beautiful. Okay. So now let's look at number 3. So notice our directions for number 3. Not only do we have to solve it, we also need to graph it. So we are doing two things here. We are going to solve the inequality, but then we are also going to graph it. Okay, so since we have to solve it first, I'm going to go ahead and rewrite it down here. So 13x is less than or equal to negative 91. Okay, so we're going to solve this the exact same way we'd solve an equation. Draw a line down your equal sign, or in this case, inequality signs, excuse me. Okay, look at the side with your variable. That's this left side. It has this 13 that's being multiplied to it. So what is the opposite of times by 13? It's going to be to divide by 13. Okay, so we have x is all that's left over. We still have our less than or equal to sign. Okay, negative 91 divided by 13. In fact, I'll show you guys that you can always use a calculator. Negative 91 divided by 13 is going to give me negative 7. Okay, so we know that for number 3, sorry, a little shaky. For number 3, x is less than or equal to negative 7. Okay, so my variable is all by itself, so we can go ahead and graph it. Okay, so on what number on my number line am I going to put my point? I'm going to put my point at negative 7, which is actually right here between negative 6 and negative 8, right? And is this going to be an open or a closed point? This one's also going to be a closed point because of that or equals to. And now we need to shade. So this is saying x is less than or equal to negative 7. Okay, so where are my numbers on my number line getting less than or smaller? to the left, right? Just because it says -8, right? These numbers might seem bigger, but whenever it's saying less than, you always think go towards the negatives. Okay, you could also have thought my variable came first, so my sign points to the left. Beautiful. Okay, let's look at number 4. So we need to solve this before we graph it. So I'm going to rewrite it. 28 is greater than or equal to -7 plus 7 times r. Okay, so start solving it the exact same way. Let's draw a line down your inequality sign. And let's look at our side with our variable. So which 7, I see a couple 7s that are attached. Which 7 do I need to get rid of first? Do I need to get rid of this subtract 7 or the times by 7? I need to get rid of this subtract 7 first. So what is the opposite of -7 or subtract 7? It's going to be to add 7. Okay, so we got to do the same thing to both sides. Okay, bring down what's left. We have 7 times r is left. We still have our same sign. Okay, then what is 28 plus 7? It's going to give me 35. Okay, we are not done because my variable is not all by itself. So we still need to get rid of this times by 7. What is the opposite of times by 7? Divide by 7. Okay, so divide by 7 on both sides. We get r is all by itself on this side. We still have our same sign. But what is 35 divided by 7? 5. Okay, so my r is all by itself, my variable, so we get our inequality. So we can go ahead and graph it. So on what number on my number line am I going to put my point? At +5, okay, that's right there. Is this going to be an open or a closed point? It's going to be closed because of that or equals to. Okay, so closed point on 5. Okay, now notice that our variable did not come first. Our 5 came first. So we need to look at what it's actually saying. This is saying r is less than or +5. So where are my numbers getting smaller or less than 5? To the left. Okay, so now you could have also thought, okay, well, I like using the little trick. Well, then just switch it around. So r is less than, because the gator still wants to eat the 5, less than or equal to 5. Okay, then you could say, all right, my sign is pointing to the left, shade to the left. Okay, beautiful. So 1 through 4, we were graphing inequalities. Okay, so let's look at number 5. Is number 5 an inequality? Look at the sign. Look at that sign right there. Is that an inequality? Nope, it is an equation. And not only that, it is a linear equation, meaning when you graph it, it's going to create a straight line. Okay, so this linear equation is in slope-intercept form. So let's make a couple notes right here on your paper. This equation is in slope, whoa, might want to spell that right, intercept form. Okay, slope-intercept form is always written as y equals mx plus b, which you guys know. But let's see if you guys know what this m and this b actually represent. Okay, what is the number, or think slope and or intercept, which one is always right in front of your x, your slope or your y-intercept? That's going to be our slope. Okay, so if the m is our slope, what is our b? That is going to be our y-intercept. Okay, so now let's write just below that. Let's write down our steps for graphing. Steps for graphing equations I'm going to add. Okay, remember you guys can use these notes on your test, so I highly recommend. Okay, steps for graphing equations. So number one, our first step is to start with your y-intercept. You guys know that that's your starting point. Okay, and then our second step is to use the slope to count to the next point. And those are our two steps for graphing equations, okay? In a little bit, we'll go over the steps for graphing inequalities, but for right now, we're just graphing a linear equation. Okay, so let's look at number 5. So the first two things we need to identify in order to graph this is what is our slope and what is our y-intercept. Okay, so what is my slope? What is that number or fraction that is right in front of that x? It's going to be -1/5, which is great because it's already in, sorry, don't have a lot of room. It's already in rise over run, right? It's already in fraction form. Okay, well, what's my y-intercept? What is the number that doesn't have an x attached to it? Usually at the end of the equation. Excuse me. It's going to be that -4. Okay, so -4 is our starting point. So we have, find -4 in your y-axis. That's right there. Put your first point right there. Okay, so now we are going to use our slope to count to our next point. Okay, so my slope is going to be -1/5. So down 1 and over 5. So from your starting point, go down 1 and then over 5. 1, 2, 3, 4, 5. Okay, connect those 2 points with a straight line and you are done. Okay, but notice since our slope was negative, okay, so negative slope, the line will go down to the right. Okay, flip your paper over and let's go to number 6. Okay, so notice that these guys are not equations anymore. These guys are linear inequalities. Okay, so down here in this big open space, let's write our steps for graphing inequalities. Steps for graphing inequalities. Okay? So our first two steps are going to be exactly the same as graphing equations. So start with your y-intercept, that's your starting point still. Then the second one is to use your slope to count to your next point. Okay, but here's where we have a couple extra steps. Okay, so our third step is to decide if this is going to be a solid or a dotted line. Okay, so decide, is this going to be a solid or a dotted line based on the inequality sign? And then our very last step is going to be to shade. Okay, so those are our steps for graphing inequalities. We have just a couple extra ones when it comes to inequalities rather than equations. Okay, so let's look at number 6. We are going to start this the exact same way we would start an equation. Okay, so first, what is our slope and our y-intercept? Okay, so what's my slope? What is the number that is right in front of that x? going to be that 6. Okay, or you can rewrite it as 6 over 1 if you want that rise over run, right? Okay, what's my y-intercept, the number on the end of the equation? It's going to be that positive 2. Okay, so find positive 2 on your y-axis. It's going to be right there. And put your first point at positive 2. Y-intercept, y-axis. Exact same steps. Okay, so now we need to use our slope to count to our next point. So our slope is up 6, rise 6, and run 1. Okay, let's see if we can do that. 1, 2, 3, 4, nope. Okay, if we go up 6, we're going to go off the graph. So let's go down 6. Let's go backwards. 1, 2, 3, 4, 5, 6. Okay, but in order to keep my line going up and to the right, go back 1. Sorry.
To announce that we have bagged breakfast and lunch for students on your way out. If you're in need of lunch or breakfast for tomorrow, you can grab a bag on your as you exit the building today. Also, if you're in further need of any types of food, the Hawk Stash is open in room 1110. Thanks. Have a great day.
Sorry about that. Okay, so I had to go back 1 in order to keep my line going up and to the right because it's a positive slope, right? We'll make that note in a second. Okay, so we did steps 1 and 2. We started with our y-intercept and we used our slope to count to our next point. Now our third step is to decide, is this going to be a solid or a dotted line? Sorry, just bumped my thing. Solid or a dotted line based on my sign. Is that going to be a solid or a dotted? That's going to be a solid line because it has that or equal to, kind of like the filled in point. So solid line. Okay, and the last thing we need to do is shade. Okay, so now this is saying, if this is saying y is less than or equal to this inequality. Okay, where are my y values getting smaller? Am I going to shade the y values up or down? Where are they getting smaller? We're going to shade them down. That's where they're getting less than, which means you're going to shade on that whole side of that line. Okay, last note I want us to make right there. Because this slope was positive, we already made a note about a negative 1. Okay, but a positive slope always goes up to the right. Beautiful. Okay, so we graphed it, we did all the extra steps, we had a solid line, we shaded, we are good. Okay, so let's look at number 7. Okay, so same exact way we're going to start. What is our slope? And what is our y-intercept? So what is my slope? What is right in front of that x? It's going to be that 2 over 5, which is great because it's already in rise over run. Okay, what is my y-intercept? It's going to be that negative 2. Okay, that's my starting point. I find negative 2 on my y-axis. Put my first point there. Okay, now I'm going to use my slope, which is rise 2 and run 5. So from our starting point, let's go up 2, 1, 2, and then we are going to run 5. 1, 2, 3, 4, and 5. Okay, we did steps 1 and 2, but before we can connect these 2 points, we need to decide, are we going to connect it with a solid or a dotted line based on our sign? This one is going to be a dotted line. Okay, so dotted line connects these 2. Arrows on the end. And now our last step is going to be to shade. So if this is saying y is greater than, where are my y values? Look at my y-axis. Where are they getting bigger? Am I going to shade up or down? I'm going to shade up. That's where they are getting bigger, which means I shade that entire side of the line. Beautiful. Okay, awesome. Let's do our last example. Okay, so our last example, we're back to graphing equations. Okay, these guys are both equations again. Okay, but notice now it's a system, which just means more than one. Okay, we have more than one equation we have to graph here. So let's start with our first one. Okay, so looking at that top equation, what is my y-intercept? First, we won't even write these out, okay? So what is my y-intercept of my green equation? What's my starting point? It's going to be that positive 4, right? So positive 4. Okay, now what is my slope? It's going to be that 1 over 4. So rise 1, right? Rise over run. So we're going to go up 1 and over 4. 1, 2, 3, 4. Okay, because this is a system of equations and we're trying to figure out the point where they intersect, I'm just going to use slope again to put another point on my graph. So instead of going up 1, excuse me, I'm going to go down 1 and back 4. 1, 2, 3, 4. Okay, still a straight line. Boom. Our first equation is graphed. Okay. Now let's go ahead and graph our second equation. What is the y-intercept of my second equation? Y-intercept doesn't have an x attached, so it's that -3. So find -3 on your y-axis, right there. Okay, now let's use our slope to count to our next point. Okay, so we have our slope of -3 over 2. So we want to go down 3 and over 2. But 1, 2, we'd go off the graph. So let's go up 3 and back 2. Okay, so 1, 2, 3, 1, 2, because my line is negative, it's got to go down. Okay, I still haven't found a point where they connect, right? But let's keep going. 1, 2, 3, 1, 2. There we go. Okay, so we found the point where they intersect. Okay, we graphed it, but what we're actually looking for is the point where they intersect. That is the solution. So what is that coordinate point? Always line it up with your x-axis first. So our first is -4 on our x. Okay, then go up to your y, lines up with 3. Okay, so the answer, the solution to this system of equations is -4, 3, x, y. Okay. Your notes are all filled out. I linked a blank copy as well as the filled out copy on Canvas. Your review assignment you should do next, and then your test will be next time on Wednesday.